Problem sheet 7, question 4. Finding the longest common subsequence between two sequences is a useful problem to solve. For example, it can tell us how similar two strands of DNA are. Use dynamic programming to find the longest common subsequence between ACT-AGCTA and TCA-GGTAT. Now, this is a very difficult problem, so if you can't solve this on your own, don't worry too much. This is mainly here so that we can demonstrate the power of dynamic programming and various problems that we can solve with it. So there is a hint. Consider the triples IJK as states. These correspond to the ith element of the first sequence and the jth element of the second sequence. We only need to consider states where the letters K are identical. For example, the state 13A, denoted by the letter A, is shared by the first letter of the first sequence and the third letter of the second sequence. Okay, so to start off this dynamic programming problem, again we need to first formulate this as a directed acyclic graph before ordering the states, performing value iteration and reading off the solution. So the hint is giving us an idea of how we can start formulating this as a directed acyclic graph. So first of all, let's consider all the possible states that are in this system. So to consider all possible states, let's look at all the possible places where two letters can coincide in these sequences. Let's first look at where can A collide. So we have an A here and an A here. This will correspond to the state 1, 3, A. That is, there is an A in the first position of the first sequence, the third position of the second sequence. And how about here? That is the state 17A. There is an A in the first position of the first sequence and the seventh position in the second sequence. What other combinations do we have? We have this. An A in the fourth position of the first sequence and third position of the second sequence. And here. And here. And here. And we can repeat these for all other letters. So these are all the possible states in this problem. Each state represents a position, a letter and a position in our common subsequence, and one can only precede another if their positions in the original sequences precede each other. So for example, S1 and S2. S1 precedes S2. Its position in the first sequence precedes, and its position in the second sequence precedes. And therefore we can say there would be an edge between S1 and S2 if S1 precedes S2. Now we can begin constructing our directed acyclic graph from this information, but we can simplify this a little bit more. Let's consider the t's. Now the first time two t's coincide would correspond to 31t. The next time two t's coincide would correspond to 76t. So there is an edge between 31t and 76t. Now there also could be an edge between 31t and 78t. However, there is no point ever taking this edge. Why? Because there may be letters between the 6th and 8th position, which as we skip over those, we will miss out on. So this edge will never be optimal. If it is optimal, then this would also be optimal, and they are both optimal, and we might as well take the first, or it is not optimal. And therefore, there is no point constructing that edge. So we will begin constructing this directed acyclic graph, only drawing edges from a state to the immediate next instance of each letter that can come. In drawing the graph, we'll need a starting point, which will be the start of our common subsequence. So let's call that state 0, 0 star, as it does not represent any letter. From there, we can go to the first A, the first C, the first T, or the first G. From each of these, so from the first A, we can go to the next A, the next T, the next G, but we cannot go to the next C, as this represents the third letter of the second sequence, and the only C in the second sequence is the second letter of the second sequence, so we cannot reach a C from here. And we can carry on constructing this graph until we've covered all our states. And so our directed acyclic graph would look like this. Notice there are some states missing. For example, the state 55G. Why is that? Well, any state that precedes 55G also precedes 54G. And it wouldn't make any difference whether we went to 54G or 55G. So as I said before, some of these edges can be missing. Well, if the only edge that will go into a state is missing, then that state itself is missing. And that's fine. We've realised that that is the most efficient way of drawing this graph. Following that edge will either be co-optimal or never be optimal. So we're not going to be missing out. We would now like to order the nodes so that as we are going through and analysing them from 0, 0 star to some endpoint for this sequence, we are analysing in such a way that we've already analysed all a node's ancestors before we reach that node. Now there is a natural order in here because we're looking at a sequence, and that order is which node precedes which node. For example, 54G always precedes nodes with a bigger first index and a bigger second index. We'll order the nodes in the following way. So the ordering is quite natural here. We order them by the first index and the second index. What would be the reward associated with each edge? Well, what does following an edge mean? It means adding a letter to our common subsequence. So if we care about the length of the common subsequence, adding a letter would contribute an additional length of 1 to that subsequence. So each of these edges has a reward of 1. Okay, now I'm going to start the value iteration. So we are going to start from a particular node, and we're going to follow an edge to another node. Each edge contributes a reward of 1, so that column will be kind of pointless here. But what would the result of adding that reward to the previous node's value be? And therefore, what is the current node's value? So we'll start at 0, 0 star. We cannot go anywhere from here. That is our initial node, so that has a value of 0. Our next node to analyse is 1, 3A. We can get there from 0, 0, star. Notice this time we are traveling backwards along the edges. As long as we are consistent, that's fine. If we did this, we'd add 1 to the value of 0, 0, star. That's the only action to take here, and so 1, 3a has a value of 1. Now we'll look at 2, 2c. From here, we can only go to 0, 0, star. Now 3, 1t. Again, we can only go to 0, 0, star. How about 3, 6t? So from here, we can go either to 1, 3a or 2, 2c. Either way, this would get a value of 2. Next, we will analyse 4, 3a. From here, we can either get to 2, 2c or 3, 1t. Either way, that will give us a value of 2. Consider 4, 7a. From here, we can get to 1, 3a or to 3, 6t. And 3, 6t already has a value of 2, so following that would give this a value of 3, which is the highest. Next, 5, 4g. From here we can get to 0, 0, star, 1, 3a, 2, 2c, 3, 1t, and 4, 3a. There's a lot of options here. Then we look at 6, 2c. The only place we can go from here, 3, 1t. 7, 6t. From here we can get to 3, 1t. Next, 7, 8t. 8, 3a. And finally, 8, 7a. Which completes the value iteration algorithm. Now we can start reading off a solution. So the state with the largest value is 87a with a value of 5. So that's the longest common subsequence we can make. How did we make that? Well, we went via 7, 6t. 7, 6t has a value of 4. How did we make that? Well, we went via 5, 4g. How did we make that? Well, 5, 4g has a value of 3, and we went via 4, 3a. How do we make that? That has a value of 2, and there are 2 possible optimal actions here. Considering the first, 3, 1t, the best thing to do was go via the initial node, and the second one, 2, 2c, the best thing to do was go via the initial node. And so our solution here, one solution would be to go 0, 0, star, 3, 1t, 4, 3a, 5, 4g, 7, 6t, 8, 7a. Or another solution would be to go 0, 0, star, 2, 2c, 4, 3a, 5, 4g, 7, 6t, 87A. Can we interpret this in terms of a longest common subsequence? So the first solution would be 31T, would be this pairing here, then 43A, this pairing here, then 54G, this pairing here, then 76T, this pairing here, then 87A. This will be the first longest common subsequence. The second, the only difference now is the first element will be 22C here.